Alright, so let's look at rules of exponential mapping. Previously, we dealt with linear mapping. This time, we are going to look at what we call exponential mapping. We are going to find the rule. In a question, when you are asked to find the rule of exponential mapping, how you are going to go about it. So we are going to look at it quickly. Alright. But before that, let's look at what is meant by exponential mapping. In this case, we are saying that exponential mapping is a mapping in which consecutive elements of the codomain have common ratio. We are saying it is what? A mapping in which consecutive elements of the codomain have common ratio. And or it can also be what? When there is a ratio between consecutive elements of the codomain is what? Constant. When the ratio between consecutive elements of the codomain is constant. So we are going to look at when we say the ratio between consecutive elements of codomain is constant, or when we say the consecutive elements of the codomain have common ratio. So anytime a question is given to you, as I said previously in the lesson we did, or lesson we looked at in the linear equation, we said that whenever a question is given to you, you need to test them to see, yes, whether the mapping is a linear one, or exponential one, or a quadratic one. All right, good. So we'll not waste time. Let's look at the rule given for exponential mapping. So you could see that we have exponential mapping is defined by the rule. So this you see in the box here is the rule. When you are asked to find a rule of exponential mapping, this is the rule you are going to use. In this rule, we are saying y should be equal to what? A r exponent x minus what? B, where we can see that the r you see in this formula or in this relation is the common ratio. Is the common ratio. Yes, so we are saying the r is the common ratio of the elements in the codomain. Yes, that is the ratio we are talking about. Also, the A here is the first element of the codomain. So whenever you are given the mapping, whatever value you see as the first on the codomain, that becomes what? Your A. While the B part is the first element you see on the domain. All right, so we shall take an example and look at how we can find the rule of such mapping. All right, so let's take one example and look at how we can find the rule of that mapping. Great, so let's look at this example. We are to determine the rule of the given mapping where we have x being the domain of the mapping and the y being what? The codomain. All these elements you see here, 1, 2, 3, and 4 are all elements of the domain, while we have 2, 4, 8, and 16 as element of the codomain. All right. Now, what we did previously, we said that whenever it is given to you, you need to test whether it is a linear mapping. And how do we test whether it is a linear mapping? We say that when you realize that there is what? A common difference of consecutive elements in what? The domain, and at the same time there is also a common difference in the consecutive element of the codomain, then it becomes what? A linear mapping. So let's try and see if it is true. So for common difference for the domain, okay, you realize that let's look at the difference in the in the domain, you realize that when you subtract 1 from 2, you are getting what? 1. When you subtract 2 from 3, you are getting 1. When you subtract 3 from 4, you're also getting 1. So you realize that for the difference, we have common difference for the domain. But let's also test for the codomain. Once you test for domain and you realize that you have common difference, it doesn't mean you should end there. You should also test for the codomain. So if I'm to subtract 2 from 4, am I going to get what? 2. Is it the same as when I subtract 4 from 8? Is it going to give me the same? No. This is going to give me 4. What about if I subtract 8 from 16? I'm going to get 8. So you realize that we subtracted 2 from 4, we got what? 2 here, which is not the same as when you subtract 4 from 8, and also not the same as when you subtract what? 8 from 16. So you realize that the denominator or the codomain doesn't have what? Common difference. Okay, so once you realize that, then you test also for what? Exponential mapping. So it means here linearity doesn't work here. We move on to what? Exponential mapping. And what did we say about exponential mapping? We are saying that when you realize that there is a common ratio of consecutive elements in the codomain, then we have what? Exponential mapping. So let's try and see if we find a common ratio. So in finding a common ratio, what we mean is that we are going to divide what? Each element, consecutive element, by each other. All right, so we shall divide 4 by 2, which will give us what? 2. Is it the same as when we divide 8 by 4? It's also going to give me what? 2. Is it also the same as when I divide 16 by 8? It's also going to give me what? 2. So you realize that we are getting what? A ratio which is what? Constant. It is running through. We are getting the same. When you find a ratio of consecutive numbers, you are getting what? A constant. All right, that is what? 2. So once you realize that, then it means that this mapping is what? Exponential. Then you can proceed to use the general rule for exponential mapping, which is giving us my y is equal to a r exponent x minus b. All right, good. Now, how do we get my r? Remember, in the definition we said that the r is the common ratio, and we have calculated the common ratio as 2. So it means my r is equal to 2. What about my a? We also said in the definition that the a represents the first element on the codomain. So let's look at all these are the codomain. What is the first element? 2 is the first element here as the codomain. So my a is also giving us what? 2. What about b? My b is also giving us, we say that b is also the first element on the domain, and that is what? 1. So it means my b is equal to 1. Once we are able to get the values of r, a, and b, then we can just quickly substitute to the general formula, and then we get our rule. Then I can write my rule for this mapping as y is equal to 2, and then I have r. I'll put this because of the exponent. I'll put the r into parentheses. Okay, then my x, I'll bring my x minus, what is my b? My b is 1. So when you get here, you don't have to do anything to the rule. You leave your answer in this form, and this becomes the rule for such mapping. So this is how we find what? Exponential mapping. Let's try another example. All right, let's try another example and see how that one will also work. Okay, all right. Okay, let's look at the example 2. So this is what is given to us as example 2. Okay, so this one, let's quickly find the common ratio of this. Okay, let's try and find the common ratio. If we have common ratio, then it is exponential mapping. Okay, so what we are going to do is we are going to so let me start from here. We are going to divide 3 by 27, and what answer am I going to get? So I'm going to get what? 1 on 9. Is it the same as when I divide 1 on 3 by 3? Is it going to give me also 1 on 9? Yes. So when I divide it, if I reciprocate this, I'm going to get what? 1 on 9 as well. What about if I should divide 1 on 27 by 1 on 3? Is it also going to give me 1 on 9? Yes, if I reciprocate it, I'm definitely going to get 1 on 9. Good. So once this one, we are also getting common ratio, and that becomes our R. So we are getting 1 on 9, 1 on 9, 1 on 9. Okay, so this is the common ratio we have. Okay, good. Once we have this common ratio, then we can conclude that our R is giving us what? 1 on 9. And what is our A? Always we see the A in the general formula is giving us what? The first element on the codomain, which is this time this becomes what? 27. And what about my B? My B is also the first element on the domain, which is also given as -3. So I'm only going to substitute these values into my general rule. Very simple. All right, it's not difficult. That's very simple. So this is my general rule for exponential mapping. Okay, x minus b. So I'm only substituting these values. What is my A? My A is giving us 27, and I'm going to put my R, which is 1 on 9, in a bracket where I can bring the exponent x minus what? Minus negative. B is already negative, so I'll bring my negative here. Okay, -3. Good. Now since we have negative here, if I should open the brackets here, then my final rule is going to be 27, or multiplying 1 on 9, or exponent x plus 3. Good. So this also gives what? The rule for such exponential mapping. Very simple. All right, good. So that is how we find the rule of what? Exponential mapping. Okay, so we shall end here for another time. In our next lesson, we are going to look at how we can also find the rule of what? Quadratic mapping. Now, I'm your facilitator, Evans. Okay, this channel is Masris TV. Don't forget to subscribe, like, and share. Thank you very much. See you next time. Bye bye.